Good morning. Welcome to the third Fortaleza's Offshore Spring School. The third Fortaleza's Offshore Spring School is led by the Federal University of Ceará in Brazil in cooperation with the University of Salento in Italy. This year, we gathered the researchers and professors from both sides of the Atlantic to discuss about the impacts, the conservation and management, and the socioeconomic possibilities associated with the coastal and offshore areas. The main theme is dedicated to the United Nations Decade of the Oceans and the challenge that we face now and in the near future. The Fortaleza's Offshore Spring School is an initiative born 3 years ago at the Marine Science Institute, Labomar, for Federal University of Ceará. Now, we initiate a moment in which students and professionals we have the opportunity to explore new frontiers of knowledge and methods through lectures and discussions with different specialists from abroad. Good luck and a very pleasant school for everyone. Ladies and gentlemen, I would like to invite Professor Sérgio Rossi, Professor of the University of Salento and visiting professor in Labomar from Federal University of Ceará, Chair of our Spring School, for his welcome speech.
Bom dia, buongiorno, good morning, and why not, buenos dias. So this is just the entrance of this third Astral Spring School of Fortaleza here, that is sponsored by Universidade Federal do Ceará through the post-graduation program of the Labomar, but also by other people that has been working in the Cap Spring project, like for example, the Postgraduação program of the Department of Geography. I'm really honored to be here because after 3 years, they decided in third year to give me the opportunity to be the chairman of this fantastic idea that they had just 2 years ago, 2.5 years ago, in which several professionals are inside a group talking about different topics about the oceans. This is very important because in this decade of the oceans, in which the United Nations and also many programs all around the world recognize or start to recognize, truly recognize the rule of the oceans, it's important to have professionals for every part of the world. In fact, here, the idea was to gather people from both sides of the Atlantic, from basically Italy and Brazil, in this connection between these two universities that had been in touch during the last years, and in which during the last years they accelerate the process of something they sharing, not only projects, not only papers, but also educational, inspirational, and communication programs. Say that I'm very proud to just have this opportunity to present you professionals about several targets, like for example, impacts, coastal management, ocean management, and also blue growth. In this framework, we will try to be to make this kind of talks and also to translate this kind of talks to a special issue of the journal of Labomar, which is Arquivos de Ciencias do Mar. In a near future, probably at the end of the year, you will have some of these talks translated to papers. These talks that I repeat are centered in opinions, perspectives, focus on different problems and different solutions of the oceans. Thank you very much. Livia, all yours.
Thank you, Professor Rossi. Next, I invite Professor Luiz Ernesto Arruda Bezerra, coordinator of the postgraduate course in Tropical Marine Science from the University of Ceará, for his pronouncement.
Thanks, Livia. Good morning, everyone. As Livia said, my name is Luiz Ernesto. I am the coordinator of the postgraduate program in Tropical Marine Science at Federal University of Ceará. And it is with great joy that we open the third edition of our international school, Fortaleza's Austral Spring School. This year, we have a partnership with the University of Salento in Italy through our dear visiting professor, Sérgio Rossi, who is the chairman of this event. In addition to our colleagues from Italy, we will have the participation of researchers from Brazil and Spain. This is a unique opportunity for our students to interact with researchers from different parts of Brazil and the world. In the next 3 days, we will discuss the oceans, their impacts, and how we can preserve them for future generations, remembering that from 2021 to 2030 is the United Nations Decade of the Oceans. As in the 2 previous editions, I'm sure that this 3rd edition will be a great success. I would like to thank the post-graduation program of the Faculty of Law and post-graduation program in Geography of Federal University of Ceará for their support, and the Brazilian Agency of Post-Graduation Program, CAPES, for the grants as well. My special thanks to organizing committee that worked hard the last days so that this school could happen in the best possible way. So welcome everyone to Fortaleza's Austral Spring School and have a good event. Thank you. Lívia. Austral Spring School and have a good event. Thank you. So, Lívia, I think you are in the screen.
Thank you, Professor Bezerra. Now I'd like to invite Professor Maria Odilea Bezerra Menezes, Director of the Marine Science Institute, Labomar, for her pronouncement.
Vice-reitor, exercício da Universidade Federal do Ceará, professor José Glauco Lobo Filho, ilustríssimo senhor pró-reitor de Relações Internacionais e Desenvolvimento Institucional da UFC, professor Augusto Teixeira de Albuquerque, ilustríssima senhora delegada de Assuntos Internacionais da Universidade de Salento, professora Rosita de Amora, ilustríssimo senhor diretor do Departamento de Biologia e Ciências Ambientais e Tecnológicas da Universidade de Salento, professor Ludovico Vale, ilustríssimo senhor coordenador do Programa de Pós-Graduação em Ciências Marinhas Tropicais, professor Luiz Ernesto Bezerra, ilustríssimo senhor coordenador da 3ª Fortaleza Austral Spring School, professor Sérgio Bezerra, em nome de quem agradeço a toda a comissão organizadora, ilustríssima senhora vice-diretora do Labomar, professora Lidriana Pinheiro, em nome de quem agradeço a presença de todos os professores, ilustríssima senhora doutora Thalita Tavares e ilustríssimo senhor Abraão Andrade, em nome de quem agradeço a presença de todos os técnicos. Ilustríssima senhorita Ravene Stephanie Alves e ilustríssimo senhor Marcos Davis, em nome de quem agradeço a presença de todos os estudantes. Ilustríssima senhora professora Patrícia Siveri, do Instituto de Ciências e Tecnologia Ambientais, da Universidade Autônoma de Barcelona, em nome de quem agradeço a presença de todos os palestrantes convidados. Ilustríssimo senhor professor Carlos Teixeira, em nome de quem agradeço a presença de todos os mediadores convidados. Saúdo, igualmente, as demais autoridades presentes e os participantes da terceira Fortaleza Austral Spring School. Senhoras e senhores, bom dia! É com muita satisfação e honra que estamos aqui hoje, presente nesta solene abertura da terceira Fortaleza Austral Spring School. A Fortaleza Austral Spring School é uma realização do programa de pós-graduação em Ciências Marinhas Tropicais do Instituto de Ciências do Mar, do Labomar, da Universidade Federal do Ceará, realizada em parceria com a Universidade de Salento, na Itália. Parabenizo o professor Sérgio por ter enfrentado o desafio de realizar um curso desta magnitude e do qual muito nos orgulhamos. É um prestígio compartilhar com a Universidade de Salento um curso no formato de masterclass de alto nível intelectual. É uma alegria estarmos na terceira edição dessa escola, que vem contribuindo com o avanço das ciências do mar. Lamentamos todas as mortes pela Covid-19 e somos solidários a todas as famílias, devido à pandemia da Covid-19, no qual as restrições de segurança sanitária impossibilitaram as nossas atividades presenciais, tivemos que nos adaptar ao formato online e foram superadas todas as dificuldades iniciais. Aprendemos muito neste formato online. Aprendemos a fazer uso de uma técnica e a Fortaleza Austral Spring School ampliou sua inserção nacional e internacional, com o maior número de palestrantes do Brasil e de outros países, como Itália, Espanha, México, França, envolvendo 12 instituições, 5 instituições brasileiras e 7 instituições de outros países. Dentre estas, 5 universidades brasileiras, além da Universidade Federal do Ceará, a Universidade Estadual de São Paulo, a Universidade Federal de Santa Catarina, a Universidade Federal da Bahia, a Universidade Federal de Pernambuco e 4 universidades estrangeiras, a Universidade Autônoma de Barcelona, na Espanha, Universidade de Salento, na Itália, Universidade de Bolonha, na Itália, e a Universidade Politécnica de Sinaloa, no México, e 2 centros de pesquisa. O Centro de Estudos Avançado de Blanes, do Conselho Superior de Investigação Científica, o CSIC, da Espanha, e o Centro Nacional de Pesquisas Científicas francês, o CNRS francês, através do Laboratório de Ecogeoquímica dos Ambientes Bentônicos, em Banhus, e uma empresa que trabalha com tecnologia de conservação no oceano, a Underwater Gardens International, em Barcelona, reunindo, portanto, 19 palestrantes, destes 8 brasileiros e 11 estrangeiros. A terceira Fortaleza Austral Spring School também alcançou um número bem maior de participantes, muitos dos quais são de outros países, como Hong Kong, Nepal, entre outros. Hoje, contamos com mais de 300 inscritos. Portanto, essas dificuldades iniciais ajudaram a avançar em algumas áreas. E, tendo por base esse contexto, destacarei aqui 3 pontos que considero que foram fortalecidos. O primeiro, a internacionalização. O segundo, a ciência aberta. E o terceiro, o patrimônio humano, como recurso mais importante de qualquer instituição. O ponto 1, internacionalização, a nossa Constituição, a Constituição Federal Brasileira, no artigo 207, ela prevê que as universidades brasileiras obedeçam ao princípio de indissociabilidade entre ensino, pesquisa e extensão. Entretanto, junta-se a esses um outro eixo, um quarto eixo, um eixo transversal por natureza, a internacionalização. A internacionalização é um dos princípios norteadores da UFC e fomenta o trabalho em rede de colaboração. Na contemporaneidade, a colaboração interuniversitária é em redes, formados por grupos nacionais e internacionais de pesquisas. E por quê? Porque a capacidade de criar novos conhecimentos, ampliar e trabalhar em rede possibilita explorar diversidade de competências que são complementares, internas e da própria universidade, da UFC, e externas de outras universidades nacionais e internacionais. A renovação de talentos e de ideias, ela é vital. Por isso, também, temos que idealizar uma oferta curricular mais rica e adaptada aos novos tempos da era global, promovendo o compartilhamento científico e cultural. Um fator limitador para atrair estudantes internacionais é a escassa oferta de cursos em língua inglesa. Temos o dever de preservar a língua portuguesa, mas também podemos ofertar componentes curriculares em língua inglesa, principalmente em cursos de pós-graduação. Adaptar-se à realidade, não se isolando e tendo sempre no pensamento que a Universidade Pública Brasileira assumiu perante a sociedade o compromisso de desenvolvimento baseado no conhecimento. A esse respeito, simultaneamente a esta organização da terceira Fortaleza Austral Spring School, iniciou-se a construção de um convênio entre a Universidade Federal do Ceará e a Universidade de Salento, na Itália, favorecendo a possibilidade de lançamento de um processo global e transversal ao UFC de mobilidade acadêmica internacional, processo desejado por muitos estudantes e professores como forma de integração entre as comunidades internacionais, de integração entre o Brasil e a Itália. A terceira Fortaleza Austral Spring School fortaleceu parcerias, fortaleceu estratégias internas e externas que conduzem ao fortalecimento da identidade de uma universidade internacional. A UFC contribuindo ao progresso do país e potencializando a referência internacional do Brasil. O segundo ponto que eu gostaria de destacar, que foi fortalecido, foi a ciência aberta. A Fortaleza Austral Spring School é no formato de ciência aberta. Foi operacionalizada uma plataforma para transmissão de masterclasses multidisciplinares para compartilhar o conhecimento gratuitamente e para todos do planeta. Então, reforçando uma identidade e responsabilidade coletiva deste patrimônio científico, o diálogo entre os povos. A crise do coronavírus nos ensinou que a ciência deve ser aberta, ter acesso às publicações científicas é importante. A ciência aberta favorece a educação inclusiva. A terceira Fortaleza Austral Spring School promove a educação inclusiva. Essa é uma oportunidade para mostrar à sociedade nacional, à sociedade internacional, a importância da Universidade Pública Brasileira e dos servidores públicos brasileiros, com o compromisso da ciência estar a serviço da sociedade. A ciência da melhor qualidade está à disposição da sociedade, como nesta escola, na terceira Fortaleza Austral Spring School. A Universidade Pública Brasileira tem um papel chave na democratização do conhecimento e da igualdade de oportunidades, na medida que as oportunidades dependem da educação e do compartilhamento de informações. A educação, ela promove a distribuição de renda. A educação é a política pública mais efetiva para distribuir fonte de renda, para promover a distribuição de renda e diminuir as diferenças sociais. Por estas razões, a Universidade Pública Brasileira tem a legitimidade necessária para que o Estado a defenda em nome dos seus cidadãos e também para que os cidadãos a defendam para evitar prejuízos à sociedade. A terceira Fortaleza Austral Spring School tem acesso aberto à sociedade, então reforça o conceito de transparência na gestão pública e da responsabilidade social. O terceiro ponto que considero que foi fortalecido com a terceira Austral Spring School foi o patrimônio humano. Para se ter uma universidade, para se ter uma unidade acadêmica inovadora, moderna, vanguardista e puxante, nós temos que contar incondicionalmente com o recurso mais importante, mais valioso para implantar essa estratégia com sucesso. As pessoas. Devemos saber, obviamente, atrair as pessoas, incorporar as pessoas, potencializar as pessoas, fixar as pessoas, dando às pessoas a liberdade para prosperar. Só assim se faz uma universidade para o futuro. Se não envolvermos as pessoas, se não envolvermos os estudantes, se não envolvermos os técnicos, se não envolvermos os professores, se não envolvermos os pesquisadores nesse processo, não teremos êxito. São as pessoas que conseguem projetar as suas universidades, são as pessoas que conseguem projetar a UFC, são as pessoas que conseguem projetar o Labomar, são as pessoas que conseguem projetar suas instituições, são as pessoas que conseguem trabalhar em parceria com as pessoas de outras instituições. São as pessoas em conjunto, em união, que compartilham sinergias, potencializam o tecido socioambiental e econômico de cada país, de cada nação. Por isso, as pessoas são o maior patrimônio de qualquer instituição. São as pessoas que conseguiram realizar a terceira Fortaleza Austral Spring School. E isso só foi possível porque teve a contribuição das pessoas e de cada um individualmente, que representa cada uma das 12 instituições aqui presentes e que colaboraram e colaborarão efetivamente para essa terceira edição. A comissão organizadora, todos os palestrantes, todos os moderadores, quero manifestar o nosso profundo agradecimento pela generosidade em se dispor a compartilhar os seus conhecimentos. A todos, o meu, o nosso, muito obrigada. Aqui, aos participantes, quero também deixar uma mensagem. Asseguro aos participantes que, na terceira Fortaleza Austral Spring School, encontrarão o melhor ambiente para discutir sobre os impactos, a conservação, a gestão e as possibilidades socioeconômicas associadas com as áreas oceânicas e costeiras. Aos participantes, desejo também o espanto, como sinalizou Aristóteles. O começo de todas as ciências é o espanto de as coisas serem o que são. O espanto é o ponto de partida para o conhecimento. Então, sejam todos muito bem-vindos à terceira Fortaleza Austral Spring School. Sejam todos muito bem-vindos ao Instituto de Ciências do Mar, ao Labomar. Sejam todos muito bem-vindos à Universidade Federal do Ceará. Uma boa terceira Fortaleza Austral Spring School para todos.
Thank you, Professor Menezes. Next, I would like to invite Professor Ludovico Valli, Director of the Department of Science in Biological and Environment Technology, to deliver a welcome speech.
Okay, thank you, Livia, and dear colleagues and students, I'm really happy and proud to share with you the opening ceremony of the third Fortaleza's Austral Spring School on Conservation, Management and Blue Growth in the Decade of Oceans. I'm also pleased to observe the participation of several colleagues from my Department of Biological and Environmental Sciences and Technologies. This is also the consequence of the effective and great work of Professor Sergio Rossi, who is really a strong-willed teacher and researcher. This is confirmed by the organization of this school and also by the collaboration settled between the University of Salento here in Lecce and the Universidade Federal do Ceará. This is a fundamental contribution to the efforts of our universities to contribute to the internationalization, which is of paramount importance for both didactics and research activities. This is a very important item, not only from the point of view of a cultural and economical aspect, but also from an ethical point of view. The importance derives from the observation that culture and research affect social and emotional development. The impact of research and cultural contexts on social and emotional development is likely to occur also through the organization of such schools and meetings and, in the later years, through their peer interaction. What is cultural development? It is the sum of all processes of enabling cultural activities towards the realization of a desired future, particularly of a culturally and vibrant community. In this sense, the contribution of the third Fortaleza Spring School is of paramount importance. Therefore, my compliments to Sergio, all the other organizers, delegates and students who have to take advantage from this important meeting. Thank you for the chance you have given to me to take part to the opening ceremony. Gratefully, I say ciao to you all. Thank you again.
Thank you, Professor Valli. Next, I would like to invite Professor Rosita da Mora, Delegate of International Affairs of Unisalento.
Hello, everybody. Ciao to everybody. I'm very happy, as well as my colleague Professor Balli just said, to be here. It is a great pleasure for me to be among the invitee of this open ceremony of the third Fortaleza Austral Spring School. So I would like to convey my greetings and my best wishes to all the colleagues of the Universidade Federal do Ceará of Fortaleza, and also to my colleagues, to the many colleagues of the Department of Technological, Biological, and Environmental Science of the University of Salento. I'm also here to convey the greetings of our rector, Professor Fabio Pollice, who could not be here today, but who asked me to wish you the best beginning for this very interesting school. I am the Pro Vice Chancellor for International Affairs, and I think it is these events like these are of the greatest importance, and we are really demonstrating that despite the very difficult times, the very dire times we are living in, for us to have links with our partners all over the world is a very strong commitment for us at the University of Salento. Our university has very strong links with Brazil in particular. Despite the distance, we have many of our colleagues have academic connection with partner universities in Brazil. And we are very proud of being one of the few universities in Italy that teaches Portuguese, but Brazilian Portuguese. We don't teach Portuguese, the other Portuguese. We teach Brazilian Portuguese, and we have two colleagues from Brazil who do a very good job with our students. So we feel particularly close to Brazil also because there are very fields of interaction between Brazil and Salento, and interaction that range from philosophy to law studies, from distance language teaching to economics, and of course to the wonderful work that our colleague Sergio Rossi is doing, and of which we are very proud of. So my special thank goes to Professor Rossi for this wonderful opportunity he gave our university. The topic of the Spring School, I think, is absolutely fascinating and addresses the very urgent issues of conservation and management of one of the most precious resources that we have. I must confess that my field of expertise does not allow me to appreciate totally the scientific debate that is going to be the scientific contents that are going to be discussed in the next few days. I'm a literary person. I teach literature, so for me the ocean is mostly a kind of metaphoric idea. And I must also confess, my second confession is that I've never been personally in Brazil, and just before the meeting, in wishing that this kind of meetings could take place soon in presence, I gave I had a look of Fortaleza to see where you are located, to imagine you in your hometown, in a town that is opening up to spring while we are preparing to winter. And I saw that these wonderful images of a city that overlooks the sea. Lecce, where we are at the moment, is not on the sea, but is very close to the sea. So I would like to imagine this blue element connecting ideally the both of us. And finally, I would also express my greatest appreciation for the very passionate message of the colleague Professor Menezes, because I really agree that it's really important that this spring school is completely free, that is para todos, as Professor Menezes has said. And also, I wish to emphasize how strongly I believe that the role that public university has is of the greatest importance for the development of the society. So it's, again, I would like to convey my best wishes for a wonderful spring school, and especially I'm sure that it will be very profitable for all the students who are going to attend it. Thank you very much for inviting me again, and hopefully we will be able to see each other in person soon, and we will be able to host you all here in Lecce. Thank you. Thank you, Livia.
Thank you. Thank you for your speech, Professor Damora. Now I invite the Pro-Rector of International Affairs and Institutional Development from the Federal University of Ceará, Professor Augusto Teixeira de Albuquerque.
Hi, everyone. Good morning. With great satisfaction, I participate in this open ceremony. This is an extremely relevant topic for nations. If, on the one hand, the pandemic imposed travel restrictions, on the other hand, it made us realize the effectiveness and scope of virtual meetings like this one. I would like to wish an excellent event for all participants. Thank you very much.
Thank you, Professor Albuquerque. Now, to close our opening ceremony, I am honored to invite the Vice Rector of the Federal University of Ceará, Professor Glauco Lobo, for his honorable speech.
Bom dia a todos. Inicialmente gostaria de dizer que é uma honra muito grande e eu transmito aqui essa honra em nome do nosso magnífico reitor, professor Cândido Albuquerque. A importância da participação da Universidade Federal do Ceará, juntamente com a Universidade de Salento, na elaboração desse terceiro encontro para estudos dos problemas envolvendo o nosso grande oceano, que é responsável o maior impacto na nossa biodiversidade e bioecologia. Então, a nossa satisfação da universidade em participar desse tão importante curso. Gostaria também de, em nome do professor Lodovico Vale, diretor do Departamento de Biologia e Desenvolvimento Científico e Tecnológico da Universidade de Salento, e em nome da professora Rosita da Mora, representante do setor de assuntos internacionais da Universidade de Salento, saudar todos os professores aqui presentes. Em nome do professor Sérgio Rossi, coordenador desse curso, saudar todos os estudantes participantes desse encontro, e em nome da professora Maria Osileia Bezerra Menezes, saudar, diretora do nosso Labomar, do nosso querido Labomar, saudar a todos os participantes e todos os funcionários e todo o corpo docente e discente e, ao mesmo tempo, também técnico-administrativo da nossa universidade. Gostaria também de saudar o nosso pró-reitor de Assuntos Internacionais, o nosso querido professor Augusto Albuquerque, que está se fazendo presente aqui, fortalecendo a internacionalização da nossa Universidade Federal, que, através desse curso, fortalece ainda mais um dos objetivos principais dessa administração, que é a prioridade na internacionalização. E aqui eu agradeço mais uma vez à Universidade de Salento por essa oportunidade que a Universidade Federal do Ceará está tendo nesse seu grande projeto de internacionalização. Desta forma, eu gostaria de saudar a todos os participantes e dizer que a Universidade, mais uma vez, que a Universidade Federal do Ceará se sente muito honrada e muito prestigiada com toda a adesão que esse curso e toda a visibilidade que esse curso está promovendo. E, dessa forma, eu declaro aberto esse evento, ou, melhor chamando, esse terceiro curso, que eu chamaria, agora que eu vou pegar o resumo aqui, e chamaria esse curso de curso Primavera do Mar. E eu espero que na próxima primavera do nosso hemisfério sul, que no ano de 2021 nós possamos realizar, e com a presença também de todos que estão aqui presentes, o nosso quarto curso. Dessa forma, eu declaro aberto o curso. Sejam muito bem-vindos à nossa Fortaleza, seja muito bem-vindo à nossa convivência. Muito obrigado.
Thank you, Professor Lobo. Ladies and gentlemen, this is the end of the opening ceremony. I am thankful to all guests and participants. Now, we start our first session with Professor Sérgio Rossi.
Hello, everybody again. Well, now we can just start. Sorry for the delay. We had some technical problems at the beginning with the connection, and then some of the talks were a little bit just longer, shorter. Just we have to scratch a little bit the program, but don't worry, we just will start immediately. It's an enormous pleasure to have here. We will have more than 300 subscribers in this very moment, and people that is just from all over the world. I'm really happy about that, because we have this opportunity to just communicate to several places in the world, and this is an amazing thing, at least from my point of view. Now we will start with this first session, in which we will talk about impacts on the oceans. It's just divided in two subsessions. The first session will be now, and there will be 3 talks. And in the next session, that will be held later on, it will start at 8 p.m. Here in Italy, and at 15 p.m., if I'm not wrong, in Brazil, in Fortaleza. These 2 sessions will be centered on this kind of topic, which is very important. So I will introduce the first one, the first invited talk to Professor Patrizia Ziveri. Patrizia Ziveri is a research professor in the Instituto de Ciência e Tecnologia Ambiental, is this Environmental Science and Technology Institute near Barcelona, in the Universitat Autònoma de Barcelona. She has been working for many years, first on paleoclimatology, but then she was much interested not only in paleoclimatology, but also in issues like, for example, global change, and within global change in issues respect or directed to climate change, that's ocean acidification, and also to microplastics are the huge problem that we have with this kind of pollutants. So welcome, Professor Ziveri. You will be the first to talk, and the screen is yours.
Let me see if I can share the screen. Let me see. Can you see the screen?
Yes, but you have to direct in the other, because now we are seeing the presentation that you see, so you have to go to the other screen.
Just a sec, because I have to. Let me see. How is it now?
Yes.
Yeah?
Perfect, Patricia.
So, first of all, I would like to thank you very much, the organizer, and particularly Sergio, but also the friends in Fortaleza, for the opportunity to participate to this Fortaleza Austral Spring School and this particular session on impact. So my presentation today is going to deal with a very wide topic that is a changing ocean under climate change. So I'm going to present you some of the main issues that the ocean is basically confronted now with. And so the content of this lecture will include something on climate forcing on ocean systems. So we will just revise a bit what we know about this climate forcing. Then we will talk specifically about key processes, and I will just introduce you these processes like ocean acidification, warming, or deoxygenation, that are really changing very rapidly, not only the physics and the biogeochemistry of the ocean, but also, of course, all the species and ecosystem and habitats of the oceans. And we also discuss a bit the consequences of these changes in the biota. And finally, I like also to propose some solutions, adaptation, and of course, this will hopefully stimulate the discussion panel that we will have at the end of the session. So since my talk is dealing with climate change, of course, I need to show you this plot that is showing the CO2 emissions from 1959 to 2019. And of course, the climate has been always changing in Earth history, but what is really anomalous now is this, what we call anthropogenic climate change. So it's the signatures of human actions on climate. And here you see the emissions in gigatons, and the gigatons is always shown in gigatons, usually the carbon cycle plots, and they basically equal to 1 billion tons, or 1 to the 10 at 15 grams of CO2, or 1 petagram. Here you also see the lighter band that shows margin of errors, and basically here you really see that the CO2 is increasing. The data are absolutely very solid. And when we talk about anthropogenic climate change and the processes that are we going to show you, are we going to discuss later, we talk about anthropogenic perturbation of the global carbon cycles. In fact, with this anomalous and very strong emission of carbon dioxide by human activity, we are basically modifying this biogeochemical cycle that is represented by the global carbon cycle. And here you see a schematic view of how basically the source and sink of carbon in our planet. And you see the fossil fuel emission, that is like the major source. Here you see the 35 gigaton of CO2 per year into the atmosphere. And then also the land use change is the other major source of carbon dioxide. And of this carbon dioxide that is emitted through human activity, about half of that is basically accumulating in the atmosphere, and that's why we see this increase in atmospheric CO2. And then one portion of this, about, as I said, about 50%, is uptaken by the biosphere and also uptaken by the ocean. So basically, the ocean and the biosphere in general, they are helping to reduce the amount of carbon that is accumulating in the atmosphere, causing climate change and all the other processes. But the talk today is really dealing with the ocean. So we are going to focus on the ocean, and we are going to focus on how this emission of carbon dioxide that is accumulating in the ocean is in the atmosphere is actually affecting the ocean very much. So the ocean, we know very much that is basically, this is the blue planet. So this is more than 70% of our planet is covered by water, by the oceans, and is also the largest biome, the largest ecosystem that is present in our planet. So it's very key. Basically, it's key also because it's influencing climate trend and temperature. It's also regulating the atmospheric CO2. It's also we see later, but it's really important for distributing the heat at the global scale. So it's key for transporting heat from the tropics to the polar region, and also the major players of the hydrological cycles and so on. So it's really, really important for all of us, for life on the planet. And when we talk about climate and when we talk about the ocean, there are three main processes that we are going to focus on now. And one is how the ocean basically responded to the global warming, that is ocean warming. So the ocean are getting warmer. Also, another thing is that the chemistry is affected by the CO2 emissions, and the ocean are becoming more acidic, and also the oxygen content as well is impacted. So they're becoming less oxygenated, so they're deoxygenated. And here is a paper that was published a few years ago, but it's a modeling exercise that was published showing different parameters that are characterizing the surface ocean. Here you see basically on the y-axis you see for example on this plot the global sea surface warming, and here you see the year about from 1850 or so to the end of this century. On this plot here you see the data that are measured, so in this black line, and here are the projections that are depending on our basically behavior, and they are depending on the CO2 emission that we will have in the coming years. And these RCPs, they are the representative concentration pathways, and a classical one, unfortunately, the worst scenario, the business as usual scenario, is this red one. And you see with these business as usual scenarios, you see the temperature anomaly is very high. And of course, it's decreasing depending on the CO2 emission that we will have. So, but in general, we will have warming. We have warming. Warming is already happening, but the trend will depend on the CO2 emission scenarios. Also, in terms of pH, surface pH, is very clear that we have already a decrease in pH, but also the projection will depend on the CO2 emission scenarios, as well as the oxygen content here. You see the decrease, and again, you see the different scenarios. And then in terms of response of the ecosystem, here specifically you have the marine productivity, so it's a global net primary productivity change in percentages. And this is a bit more complex because I would say that it's quite difficult to model marine productivity in the futures, and you see all this scattering here. But in general here in this paper, they were presenting a slight decrease or a major decrease in marine productivity. There are other projections now, they're showing maybe slightly decrease or no decrease, or even a very slight increase. So there's a lot to do here, but in general, you see the changes that are happening. So it's a very, very change. There's a very, the ocean is very much changing. And when we look at when we talk about climate, of course, we shouldn't forget that, as I mentioned before, the climate was always changing. And the major player, of course, of climate change for our planet in the geological history is the solar radiations. And the solar radiation and the greenhouse effect are really the ones that are responsible for warming up the Earth. And so solar radiation will include the heat wave, and also is mostly absorbed by the Earth's atmosphere. But when we look at the system here, so from the poles to the tropics, and you see the solar radiations, I mean, depending on where the solar radiation will hit, either the surface of the ocean or the sea ice or the land, will have a different results in terms of albedo, for example, and also how much heat is trapped on the surface. And one of the main property of water, and including seawater, is that it has this main capacity of trapped heat. In general, what we say is that just the upper 10 meters or so of the ocean basically contain as much as heat as the entire atmosphere. So just for you to understand how important is the ocean heat for alleviating the ocean, the global warming, but you also, I mean, the resulting product is that you have the warming of the ocean at the surface. And here I also wanted to show some very solid data that are showing the warming of the ocean and this ocean heat content that is basically used for quantifying the rate of global warming. And we know that the ocean heat content has been rise since 1960. And you see here different way of plotting this ocean heat content from 1960 to 2000, basically the present. And you see the different resolution. This is like 5 years average from 2015, consider 2015, 29 is the last period that is being considered. And also here you see with the red line, the other very high resolution record where you have, of course, a more interannual type of variability. But in general, I mean, the data are super solid, and you see the ocean, the upper ocean for the upper 2,000 meters is really increasing the temperature quite drastically. And this, of course, has enormous consequences on the ecosystem, for example, on bleaching corals and mortality of many species, but as well as major and rapid change in biogeography of species and fish distribution, for example. So has really enormous consequences on the ocean's ecosystems. Also, as something that maybe we don't think about it so much, but is also very key for life and for our climate stability, that the ocean warming is impacting what we call the thermoline circulation. So it's impacting this major, what we call a conveyor belt, this transporting heat from the tropic to the high latitude. And then there are deep water formations that are formed, for example, here in the North Atlantic, and then they are redistributed all over the ocean. And basically, this changing the temperature and also the salinity by, for example, meltwater that is formed by the melting of, for example, of Greenland and so on in this area can really impact the pattern of this conveyor belt. So it can have enormous consequences on many things, including the sea level rise, including the nutrients, including the distribution of heat at the higher latitude. Another major process that I would like to introduce to you that is ocean acidification. And as the global warming, the main driver is greenhouse emissions. Here, the ocean acidification is basically only linked with the CO2 emissions rate. And the simple principle is quite simple in chemistry. So you have an increase, an excess of CO2 in the atmosphere that is a gas and is a slight acid gas, and is basically equilibrated, uptaken by the surface of the ocean that has lower CO2 concentration. So, and when this CO2 is uptaken by the ocean, is dissolving in seawater and is basically dissociated in different carbonate ions, bicarbonate and carbonate ions. And all these equations, all these processes are releasing hydrogen. And the main idea of ocean acidification and the main idea of this process decreasing the pH is because you're increasing the concentration of this proton, this hydrogen proton. So the pH that is measuring negative is the minus logarithm of the concentration of this hydrogen is basically impacted by this process. And a thing that I wanted to highlight is that often it's a bit misleading, the concept of ocean acidification, but it's linked with the concept of ocean warming. It doesn't mean that the seawater is becoming acidic, but it's meaning that it's becoming more acidic. So it's going to be more acidified. So the pH is decreasing as the temperature is increasing, and we call it ocean warming. And here you see one of the organisms that are affected by acidification. This is a planktonic calcifiers. But also, basically, at the beginning, we were thinking that the target organism will be mainly the calcifier, and they are. But there are also many other organisms that are affected by this process in many different ways. And ocean acidification is something that is really happening, and it can be measured. Now we have some long-term time series that can really show very well the process of acidification. So here is the Mauna Loa, very famous Mauna Loa station in Hawaii, so Station Aloha. Here you see the CO2 emissions, and here you see the seasonal pattern of the CO2 emission in the atmosphere. We are saying basically the ocean is breathing, and that's why you have this up and down pattern. And then more recently, in the 80s, they started also to measure the carbonic chemistry of the seawater, not only they measure the chemistry of the atmosphere, and they see that they could monitor really the response to the CO2 increase. And here you see the CO2 in green line. Here you see the CO2 concentration in this in the seawater, so dissolved CO2, and here in blue you see the decrease in pH, the equivalent decrease in pH due to this uptake of CO2 by the ocean. And this is the pattern. So this is the, as I didn't mention, but this is the oldest time series that started in the 50s with the monitoring the atmospheric CO2. Also, I wanted to show this just to show how anomalous is what we are doing to our ocean today. When we look at the historical and also geological past, here you see the record from 0 to 800,000 years. These are data from ice cores, and here are atmospheric CO2 reconstructed by ice core, and during these 800,000 years, and you see that and you see that there is the CO2 concentration is changing, but it's quite interesting to see that there's always balance between about 180 and 280 part per millions. So there is really like a way of regulating the CO2 emission by the natural system. And when you look at what we are doing today and what is projected for the future, you see that it is absolutely anomalous with this very high peak in CO2 concentrations. And when you look at the pH is difficult to reconstruct in the past, but it's possible through geochemical tools. Here you see the geochemical reconstruction of pH and this time interval, same time intervals, and you see that you have differences, but you have always also a range. You don't have never such a low value that similar to the one that are projected in this high CO2 world. So we are doing something absolutely anomalous. The last process that I want to introduce is this deoxygenations. So this is a slide I got from the International Union for Conservation of Nature. But what I wanted to highlight is, so deoxygenation is something that really came out in the last years, in the sense that now you can monitor basically deoxygenation almost everywhere in the ocean, and is linked to the ocean warming, because increased temperature will reduce the capacity of the ocean to hold oxygen in the future, and it is already happening. Another process, of course, is stratifications. When you have ocean warming, you basically build up a density layer on top of the ocean, so in the very top of the ocean. So you are reducing very much the mixing of the ocean, and so you're reducing the oxygenation of the upper ocean. And another additional problem that we have, particularly in the coastal regions, is that the oxygenation can be amplified by basically human activity, direct human activity. For example, agriculture, sewage, and so on. So can amplify very much this process. And deoxygenation is a major issue also because you can have habitat loss. They can be worsened by this problem, and also this oxygen deficiency, particularly in coastal system, in estuary, can of course can cause major habitat loss in this type of environment, and as well as basically deficiency of oxygen can alter very much biochemical cycles, but also food webs. And here what I wanted to show you something more recent. I'm referring often to this with some slide that I have to the special report on ocean and cryosphere in a changing climate. That was an IPCC report specifically on the ocean and on the cryosphere, and it was published last year. And again, here we are seeing this process of deoxygenation at the global scale. And here you see a map here comparing the upper 1,200 meters with the deep ocean, so 1,200 meters to the seafloor. And this is absolute change in dissolved oxygen over the period 1960 to 2010. And the scale here you see in the relative dissolved oxygen change in micromole per kilo for a decade. And in the red values here, of the red contour in the map, showing the decrease in oxygen. You see that is a quite generalized pattern of red, unfortunately. And the red line here, for example, this is a critical line showing that the decrease, basically there is a less than 40 micromole per kilo of oxygen already in this area. So these are like already critical contour lines showing the oxygen has been reaching critical values. But what are the many consequences? And of course, here I cannot go through all the consequences, and probably my colleagues after me will talk more about consequences of these changes. But I wanted to introduce some of the changes. And before doing that, I also wanted to mention a bit how we study these ocean changes, including acidification and warming. And I would say that most of the knowledge that we have until now based on ocean acidifications are from cultural experiment and from lab experiment in general. So testing species at different conditions and looking at the specific response of this species to this high CO2 and low pH. But of course, the natural environment is much more complex than a cultural experiment or an artificial aquarium. So this mesocosm experiment has been invented basically to link the laboratory testing monoclonal strain-specific species to community structure and community response. These are specifically for plankton, but there are also other mesocosm that are used for benthic systems. So basically in this big tank, there is a large amount of water that is trapped with the natural planktonic community. And then in this kind of mesocosm experiment, particularly this one in the picture on the left, I think this is in the subarctic, in the Svalbard regions. Here, the pH has been changed to basically influx of CO2, and then the response of the community. In some cases, really, these are like a mixture between lab experiment and mesocosm experiment, but they are basically mesocosm experiment done on this kind of pool nearby the sea, where you can also modify the temperature. So we can increase the complexity of the experiment, adding two variables, so temperature and acidification, and looking at the response of the community. And then also wanted to mention the observation in this very specific naturally acidified system. We call it CO2 vents. And there are many of them in the Mediterranean, but not only. Now there are many in many different parts of the world. And this has been used as a natural laboratory because we could monitor, we can basically survey the biodiversity, for example, in this type of very acidic to normal condition trend. And finally, of course, there is very much need, and I think more and more now is happening, field surveys and also incubation experiment on the ship, targeting specific processing and natural variability of the system. And of course, modeling is the other big component of this science. They try really to model the responses of the natural systems. And this is a study. There are many of them. This was mainly based on it's from 2013. There were several studies done after this, but this is quite a reference studies in terms of acidification in testing, basically doing a meta-analysis of published data for different species. And one of the main outcome was that it was clear that different type of organism will respond differently to ocean acidification, but of course also we know very well to other processes. Also, what it came out that the corals, shallow water coral reefs, are actually one of the most impacted species to acidification and warming. From the study was that seagrass may increase at the high CO2, but now we know that it's impacted very much by heat waves and also by other human impact. So, but from experiment we see that seagrass is increasing at high CO2. Also, fish were impacted, and also their behavior could be also affect their lifestyles, and also potentially decrease on commercial fish. I wanted to show this because it's quite emblematic as well. This is a plot that is showing at the global scale the pattern from pre-industrial to the end of the century, pattern of omega saturation state, and this omega saturation state of aragonite is basically an index that is used for monitoring the seawater in terms of capability of an organism to calcify or not. When the values are approximating 1, the values are critical, and the organism it needs a lot of energy to calcify, and eventually is not able to calcify anymore. And in this map here, you see with the spin color are the deep sea corals, and here with the dark color you see the coral reefs. And this distribution is compared to the behavior of this index, the aragonite saturation level. This is a big jump from 1994. What I forgot to mention before when I mentioned corals being very vulnerable to change in carbonate chemistry is that the corals are built up by a very specific type of calcium carbonate that is aragonite, that is a more vulnerable type of calcium carbonate. So changing in the carbonate chemistry, particularly a reduction of pH and a reduction of aragonite saturation level, can affect quickly these organisms. And you see here from 1994, then we move to 2040, you see already that when you look at from optimal to extremely low conditions, you see that already in a few decades, the high latitude are going to reach a level of aragonite saturation level that are critical for corals. And then when you move toward the end of the century, you see that unfortunately there are no optimal, adequate, or marginal levels of aragonite saturation state, at least from this model and exercise that has been published already many years ago. And you see also that in the coral reef you have like this low marginal condition. Then the other topic I wanted to mention, I don't have very much time, but I hope I can do it quickly. So this is the effect on marine organism. With my group, I work a lot on calcifiers and the impact of climate change and environmental change on this organism, and particularly on pelagic calcifiers. These are the main calcifiers that you find in the pelagic environment. So going from these are different organisms. I don't have time now to really discuss it, but these are zooplankton. So this is foraminifera, and this is apteropod, and these are coprolithophora that are also unicellular organisms. And you see here that basically what we found also recently working in the North Pacific, quantifying really the contribution of this pelagic organism, that this group of calcifier, this phytoplankton, is really contributing largely to the production. So changes in their ecology or their distribution and in classification can really impact the carbonate production and also eventually the carbon cycle. So these are unicellular phytoplankton where they have this intracellular classification. So this is the cell that is covered by this calcite plate. And this is another study, but I think I don't have very much time to go through this one. But basically, we test the temperature and acidification on this group of calcifiers. And we could see the temperature, at least in the Mediterranean, that is an hotspot for climate change in terms of warming, it will impact largely the community, even if some species possibly can actually react to the high CO2, and eventually, at least in this short-term experiment, can actually increase their productivity. Another organism that I wanted to mention in the pelagic environment is the arthropods. They are very interesting organisms. They are made up by, their shell is made up by aragonite. So as I mentioned, this delicate type of calcium carbonate that is more corrosive to acidifications, and has been also studied very much because it's used as a possible indicator of ocean acidification impact. So they're called sea butterflies, as you can imagine from this short video, the way they fly. They are macrozooplankton, and you find it basically from polar water to the tropic. And here was a simple experiment that was done on acidification, and you see how basically the shell quickly is dissolving under these conditions. And has been also studied recently how this, just removing one group of organism to an environment, for example, in the subpolar region where these organisms are quite abundant, can have enormous consequences, for example, on the predators, on the salmon's productions. And then when this acidification, of course, is combined with the other changes that are happening, these changes are quite dramatic. And just to conclude, I have a couple of slides. This is it's a conclusive, one of the conclusive slides of this report that I mentioned before on ocean and cryosphere, and it's basically highlighting the risk scenarios for the open ocean and for the coastal system. And here with these different colors, you see very high risk is in purple and undetectable is in white. And here is the related temperature increase, went from 0 to 40 degrees. In the gray bar here represent the present day from 2016, 2015 normalized. And you see already that for this type of increase in temperature, we already have effect on the epipelagic systems. But then when you have these different scenarios, so the RCPA is 2.6 or 8.5, you have quite different results in terms of impact in the different system, from the for the quelling system to the cold water corals, seamounts, canyon, and slopes. The different pictures is actually shown for the coastal ecosystem that appear to be very, very vulnerable already to the changes that we are happening now. So this is the present day, again, this gray bar. And you see that many systems, like from the salt marsh to the seagrass, and a bit also the mangroves and the kelp forest and so on, for sure the warm water corals are very impacted with the major event of mass mortality, and the rock shores already impacted. And then if we move to this the high scenario here, you see that the situation, there is going to be a major changes in terms of reorganization of ecosystems in the coastal environment. And this is again was basically a document that was for policy makers, and just considering 3 different systems. One is the polar sea, the coral reef, and fisheries. And just for the coral reef, I wanted to show that considering these 3 main processes that they just highlighted, the ocean warming, acidification, and deoxygenation, and also in this case extreme storm event that has to do basically with this anomalous warming of the oceans, will have consequences in terms of mortality, coral bleaching, erosion in coral reef structure, and also storm damage. Then, of course, this is not happening by itself, but there are also other activity the humans are doing in terms of impacting the coastal system and the coral reef. And so you have pollution, sedimentation, and extractions, and these also are destructive for the corals. And this has consequences also for us in terms of human well-being. We have loss of habitat biodiversity, we have reduced fishing yield, and loss of coastal protection. And this is also done for the other things, for example, fisheries, and for example, the polar seas. So just to conclude, what can be done? Of course, we saw that the main driver of climate change is the greenhouse gas emissions. So we still need to do a lot of work in order to do something about this in terms of lifestyle changes, in terms of individual, societal, and in terms of thinking about a novel economic model. I really strongly believe in cooperation, communication, and I really believe in bottom-up type of approach for this change, but also, of course, bottom-up. And also we need to find a science-based solution. I strongly believe that all the solutions that we have to put in place, they have to be based on solid science and risk assessment. And of course, we have to reduce other environmental stressors that are making the situation even worse. And I also wanted to show this paper that has come out very recently about this very strange and sad situation with the COVID-19. But this paper has also shown how it's possible actually to reduce quite drastically the CO2 emissions with a major life change. Of course, this is still very sad event, and it shouldn't be this the way of that we are reducing the CO2 emissions. But the study has shown that already with the change in with the lockdown and of the start in the spring, we see this decrease almost of I think 20%, something like that, in the CO2 emission. And of course, this can go back to normal when everything will go back to normal, or maybe something can change in the way we live and the way we get organized in our society. And this is the final slide that I have. And basically, even if we stop CO2 emission now, it's important that we understand that things are changing, and they already change, and they are going to change in the next years in terms of warming, acidification. So there is absolutely a need to adapt to the changes and adapt in an intelligent way. So we need to reduce the exposure, we need to action to reduce the vulnerability, and with this I want to finish, and sorry if it took a bit longer.
Thank you very much, Patrizia, for this very clarifying and very, very nice, good presentation. Really, really nice, with some complicated topics that just, as other things going all together, and try to understand them is sometimes not so straightforward. Please don't leave the studium, because then we will have this talk, and we will answer the questions of the participants, if any. So now I will present you the next speaker, which is Dr. Giuseppe Guarnieri. Giuseppe Guarnieri is a senior scientist in the Università del Salento, which has been focusing his attention basically on marine ecological processes in the benthic areas, and also in the conservation. He has been working in very large projects and take advantage of his know-how. They have been working in the Coconut Project and in the Merces Project, two very, very large European projects about, on the one side, marine protected areas and the connection and the guide to make marine protected areas as good as we can. And on the other side, in the Merces, with the restoration programs. He has been also working in restoration programs. Giuseppe, it's all yours. Now you can start whenever you want.
Okay. Do you see me? Thank you for inviting me to this very nice initiative. And yes, in this presentation, I will briefly talk about the relationship between human disturbance and the stability of marine coastal systems, based on knowledge and approaches that have emerged in the last 2 decades and my personal research experience on rocky shore ecosystem, I will illustrate the principal problem, also taking into account of some strategies for action and related difficulties and perspectives. Most of the research carried out on rocky bottom, as well as for the majority of ecological systems, deal with the concept of stability in terms of resilience and resistance. As you know, ecosystems are complex and dynamic entities, and the complexity is due not only to the number of components, biotic and not, that constitute them, but also to the several relationships that exist between them, like trophic web that are depicted in this slide. Such complexity is able to generate emerging properties so that within certain limits, ecosystems are able to maintain, regulate, and recover themselves through feedback processes and mutual control between the various components. At the same time, given the complexity, the occurrence of a change in condition or components, even apparently small, can cause a substantial change to the entire system. The disturbance related to human activities can push systems beyond their recovery capacity, for instance, by compromising very important processes such as trophic webs, or eroding the resilience potential. So make them less stable and more prone to undesirable state change. This is a map showing the potential impact related to human activities on global oceans and seas. Generally, we can see that no area in the ocean is completely unaffected by anthropogenic impact, and about the 41% are affected by multiple drivers. In some regions, these pressures are conducive to dramatic decline in the ecological state of our coast and ocean, and so a significant decline of goods and services they provide. Here, as an indirect consequence of overfishing, you can see a classical example of phase shift from highly productive cat forest to sea urchin barren grounds. In the Mediterranean Sea, we can see a similar state shift. On rocky shore, it is represented by the transition from complex and diverse macroalgal beds to barren grounds dominated by encrusting species and sea urchins. In this case, beyond overfishing, able to deplete sea urchins predators, such as sparrows, a crucial role in triggering the phase shift can be represented by the destructive and illegal date mussel fishing. Indeed, fishermen must destroy the rocky substrate and the organism living on it in order to collect the neolithic bivalve called Litophaga. Fortunately, this activity has been banned in the last 30 years in several Mediterranean countries, although the damages from this practice are still evident from kilometers of rocky shore in different regions of the basin. In this slide, a synthetic representation of the dynamics driving change in ecological systems and the action strategies to be implemented to counteract undesirable phase shift is shown. On the right based on the conceptual model by Schaeffer and colleague, two examples of ecosystem stability landscape are shown. They illustrate the change in system dynamics as a function of system state and environmental condition. Here, the slide indicated by the press-time stress regime. The first one on the left represent ecosystem that show bistable states, and the other one represent a system that show single equilibrium states. The dynamic of the system that is represented by the behavior of the ball are determined by four opposing forces. Indeed, the resiliency is represented by the shape of the landscape slice under a given environmental condition. In both cases, the key point for management in order to maintain the stability of the system in its ideal state are the same. And thus, strategies for the reduction of anthropogenic disturbance events, both chronic and episodic, support and amplify the recovery potential of the system and monitor the system both to control the condition and take timely action to achieve the two previous points and to verify that these actions are effective. One of the key tools for the management and conservation of marine ecosystem is represented by marine protected areas. Over the last few decades, the concept of protection has evolved from the protection of nature, strictly speaking, for instance, the beautiful and white place or the pristine landscape, up to the more holistic concept of protection of the marine ecosystem, and finally, the mitigation of disturbance and the support of the system resilience. This last aspect has been often hypothesized and supported with theoretical arguments, but rarely documented. Thus, several studies recently were aimed to investigate if, in addition to preserving the structure of systems from the effect of human activities, the protection is able to stimulate the dynamic properties of marine systems, such as their resilience. This was the issue addressed, for instance, in one of the studies that was carried out by a very dear colleague of mine, and the experiment carried out in a Mediterranean marine protected area simulated the human disturbance related to the practice of date master fishery, which effect has been illustrated previously, both in the no-take zone of the MPA and to unprotected control. The pattern of recovery across experimental plot were followed during 20 months at regular intervals. And the study shown that the recovery within marine protected areas was faster than outside. After 3 months, in fact, the disturbed assemblages in the protected zone almost completely recovered from the disturbance, while the unprotected one had not fully recovered within the time span covered by the experiment. Census of urchins in the studied location showed differences in their density. There was gradient in the non-protected localities. In general, the density were not so high to cause a high grazing pressure, but as a result of the simulated disturbance, they were sufficiently higher than the protection to greatly slow down the recovery and maintain the barren state in manipulated plots. Thus, the protection apparently had no effect because the untouched assemblages were comparable, but when a disturbance occurred, the increased potential for recovery due to the protection became evident. A likely mechanism is the stabilization of a herbivorous population by their predators. And the hypothesis of a top-down control of predatory fish on herbivores was supported in other studies carried out in the same MPA or in other ones, where, according to protection regime, significant differences were found in the structure of fish population in terms of number of individuals or total abundance of species diversity, but also in the predation rates on herbivorous population, like in the graph below, where predation rate were plotted in protected location and control in a study conducted in the marine protected areas of Torre Guaceto, one of the most effective and well-managed marine protected areas that we have in this area. This pattern has a cascading effect on shallow rocky assemblages, since the grazing pressure beyond certain threshold can lead to the formation of barren, as we already said, and so the disappearance of macroalgal beds. This is the case observed in another area, where overfishing, the destruction of seabed for the collection of data mussel, and the oligotrophic condition, as well as the explosion of sea urchin population, have led to the persistence of a barren state for decades, even after the MPA implementation. Here, in a pilot study conducted with colleagues, it was seen that the state of barren was reversed only with the total exclusion of sea urchins. The density were so high that even in the presence of a bottom-up control provided by an artificially increase in the nutrient enrichment, the degraded condition of barren persisted. This is an extreme situation in which the level of condition is so degraded that the recovery is not easy reversible, and where significant restoration action have been required. But where the disturbance is not able to cause a clear change in the state of the system, it is possible to detect other related phenomena, such as a change in the variability of the system. In this study, for instance, we can see that a system in which fishing has decreased top-down control over herbivores and are exposed to a number of chronic and episodic disturbances that do not take place in the protected system are in a state of precarious stability. See the red line in the slide. Therefore, it decreases their ability to absorb the fluctuation that can occur in environmental conditions, and it increases the risk that a disturbance can push them beyond the threshold that limits the change of state. This increase in temporal variability is also associated to an increase of spatial heterogeneity of unprotected assemblages. Same things was found in another study carried out in the rocky intertidal fringe. These outcomes highlight the double role of protection in promoting the stability of the system. Firstly, MPA can maintain the integrity of the structure and connection between the system components, but they can also mitigate the effect of other disturbances, whether chronic or episodic, that could destabilize it. On the other hand, they suggest a relationship between heterogeneity and stability of the system, for sure. But this relationship is, however, largely idiosyncratic, as suggested by several studies conducted to test different sources of anthropogenic disturbance. In some cases, the disturbance create heterogeneity, and in other, homogeneity. It may seem like a contradiction, but the effects depend on the level of the intensity, frequency, and whether the disturbance affects the entire system or only one or few components or processes. Systems in which the components differ and where incomplete connectivity causes modularity tend to adjust gradually to change. By contrast, in highly connected and homogeneous systems, local systems tend to be repaid by supplementary input from linked units until a critical stress level, known as tipping point. After that, the system collapses, and this is a phenomenon that is called hysteresis. Anyway, it is widely recognized that the link between spatial heterogeneity and the potential for state change can be used to detect ongoing change in the system. Spatial heterogeneity is also important at larger spatial scale to define the ecological coherence of a system. Spatial heterogeneity, otherwise called beta diversity, is a pervasive concept in ecology, since any change, genetic, biological, taxonomic, or functional in space, time, or along a gradient of environmental variation can be seen as a beta diversity. Beta diversity so can be considered a measure of ecological connectivity. If communities within a given region have most of the species in common, then they can be seen as potentially connected from an ecological point of view, because it is very likely that they have a similar functioning and they are affected by similar processes that drive their formation and maintenance. A simple and immediate way to visualize and analyze the variation in beta diversity is to draw a distance decay curve in which the similarity in species composition in space is plotted. Here, 3 different scenarios are showed. This approach was used, for instance, in the Mediterranean to compare pattern of distance decay of benthic subtidal assemblages in 2 subbasins, the Ionian South Adriatic and the Tyrrhenian Ligurian seas. In this case, the beta diversity was strongly correlated with the current circulation, and the persistence and relatively stable current acting in the South Adriatic Ionian area compared to the greater variability of those in the Tyrrhenian Ligurian sector may be at the basis of the lower beta diversity and therefore greater potential for connectivity in the South Adriatic Ionian sector compared to the other one. These high potential of connectivity in the Adriatic was also confirmed by the result of a study carried out in the framework of another European project in which I participated, named COCONED, aimed to provide guidelines for the institution of a network of MPAs. In this study, the potential for connectivity among 8 locations in the basin was investigated through the analysis of the pattern of similarity in species composition of benthic assemblages. Again, as you can see from the dashed line in the graph on the right, species composition at small scale is relatively high, and the rate of species turnover within distance is low. The study also allowed to identify areas with greater potential connectivity, while others appear more isolated. So the observed pattern has been corroborated by the outcomes of other studies of the same project, from genetic to models based on circulation and dispersion of propagals. However, data on assemblage removal aimed to see how distance decay pattern vary according to the succession stage in the recovery process show strong local component. Thus, as succession proceed, a high scale dependency in the similarity decay was observed. This outcome suggests that even after 2 years from the beginning of the studies, local processes in the pattern of recolonization of removal plots are still determinant in driving the composition of target assemblages. Therefore, connection, even if potentially existing, must be considered in a temporal context. The temporal component of connection indicates delays between potential and realized connectivity from local to regional scales. Quantifying the magnitude of such delays is crucial to determine the fragility, for instance, of a network and the actual contribute of large-scale connection to local-scale resilience. But it is obvious that strengthening system through the implementation of protected networks of MPA is only one aspect, because this strategy can be not sufficient if measures to reduce impact beyond MPA boundaries are not planned and implemented. Thus, from an integrated management point of view, it is necessary to define the priority areas in which mitigation and restoration effort can be more effective. One of the current approaches in this direction is the cumulative pressure impact assessment. In this approach, georeferenced data on pressure related to a series of drivers are used to build pressure distribution maps of target area. The approach was initially proposed on a global scale by Harper and colleagues and scaled down in various basins. However, there are studies in which problems have been raised. The first one concerned the reliability of forecast at local level. The result on a regional or basin scale can roughly orient the management, but the concrete action must be necessarily have a local dimension to define the specific responses and driver to be managed. The second problem is the assumption of the addition of impact, since we know that they can have antagonist, synergistic, neutral effects. For the latter problem, a better knowledge of the interactive behavior of the various pressure is necessary. but the sum could be a quite good approximation. For the former, it can be solved by increasing the resolution and scaling the information locally, both of the pressure and of the weight for the sensitiveness. The main problems that remain are the assumption of linear response of the system to the set of pressure. In fact, to define the impact rank, the impact score has been linearly related to the state of the system, defining the category very low, low, etc. The other crucial point is due to the uncertainty linked to the definition of sensitivity on the basis of expert opinion. So, in this study, we have applied this approach on a regional scale in the Apulia region, focusing on one of the most important and peculiar habitat of the Mediterranean, the coralligenous outcrops that are endemic carbonated bioherm, often present on our substrate below 20-30 meter depth. As I showed before, we mapped the distribution of pressure, they quantify their intensity based on appropriate indicators on the target habitats, and we followed the Alpern procedure, and so we obtain the impact score for each cell. At this point, we evaluated the actual state of bioconstruction across 26 sample sites representative of the various combination of pressure and the regional distribution of the bioconstruction. This was done in order to test if the linear relationship between impact score and Alpern's indication was consistent with our data take on the field. The results showed that model-led impact score didn't fit with the actual state of the target habitat, but also that the coralligenous response to pressures was best identified by a log-log relationship and not a linear response, as expected by the classical approach. And so the logarithmic of the state that grew with the logarithm of the impact score. This led to a completely different map of expected impact. Furthermore, we observed a significant inconsistency between the weight based on the expert opinion and the real importance of the pressures associated with a given state based on data acquired on the field. These results suggest that not only weight and resolution need to be appropriate to the context, but then an effort is also necessary to integrate system-specific responses into the formula, which may not be linear as assumed by the approach. So, to conclude, as we said several times and shown, ecosystems are very complex entity. The interaction with the social, economic, geopolitical and management factors further complicates the solution of the problems that exist in the relationship between man and the environment. After a long time in which the effect of human impacts and their management have been treated individually, we are moving towards a treatment of environmental problems in a wider perspective. This is also evident at the political level in the context and requirement of the directive issued by the Union European, such as the Marine Strategy, which refer to a series of 11 descriptors for the definition of good environmental status that we should be able to achieve. For some descriptors, such as contaminants, nutrients, things are very clear. But for others, such as seafloor integrity, biodiversity, trophic web, etc., the things are still very smooth. A future challenge will be to avoid the proliferation of these undefined ideals by identifying concrete and clearly measurable objectives. Nature responds in a complicated way to the perturbation caused by man, but very often management policy requires simplicity and immediacy in the responses to environmental problems. The first step is to admit that a complex problem, such as that of environmental sustainability, requires an articulated and complex solution. So, for the student, it is desirable that new generations that are approaching to work in environmental research will mature immediately this vision, working together towards greater communication between science and politics, rather than following the chimera of the magic number or the solution easy and universally valid, like a mask on your mouth. Thank you for the attention.
Thank you very much, Giuseppe, for this. I mean, this was a very interesting talk about mainly how to manage coastal areas, but I think that there are many, many concepts that can be extrapolated or even to or other, for example, open ocean areas, even if you are, I mean, the whole concepts and the whole set of things are really good, and we will discuss it after the last talk. Thank you very much. And now we just pass to the last talk, to the last speaker, which is Andrea Morandini. Andrea Morandini is an associate professor of the Università del Sao Paulo. He's basically a zoologist, but he has been working in taxonomy and also in biology, molecular biology and ecology, mainly on gelatinous zooplankton, but he has many other things which he has been working on. He also studied life cycles, trying to understand the functioning of the nature, to understand not only how it works, but how we can make proper conservation programs, making this kind of approaches. Thank you, Andre, and now you can make your presentation.
Okay, thank you, Sergio. Hello, everyone. Good morning, and thank you for watching us. I think we have had several interesting topics, and I will be more specific talking about the jellyfish. I will try to share my screen. Okay, let's see if it's working. And okay, let me know if it's okay, Sergio, please, because I cannot see anymore what I am showing to you.
Yes, I can see it. Fantastic. Really nice. Yes, it is.
Yeah. It is. Are you seeing the presentation?
Not now.
Not yet.
Not yet.
Yeah. Okay, now I think it's okay.
Okay, not yet. Not yet. You are okay.
Okay, I'm having a little issue here. Trying again. No.
Not yet. I think we have to talk with the. Let me see if the technician is now viable. You are not. You cannot have the. Okay, because it cannot leave you to enter. I think that. Okay. Let me see. Okay. Try again. Okay, just what I saw it just a snap during a few seconds, and then it disappeared.
Okay, sorry for that.
Yes, you have to. Yes, you have to share the screen again.
Okay, let me try it.
Okay.
Share the screen. Okay.
Not yet. It's not present yet. Your presentation. Now, yes. Now I see it.
Okay, good.
Yes. Make full presentation now.
Is it? For me, it's a full presentation.
No, it's not full presentation. You have two screens. If you have two screens, you have to center. Okay, you have to center the presentation in the screen where you have the PowerPoint presentation.
Okay, now it's okay?
Not yet. Not yet. Okay. Not yet. Try if you want. One thing that you can do that could be easy is disconnect the screen that you have, the second screen, and automatically it will be centered only the one screen that you have. Let me see now. Ta-da-ta-ta. Okay. Yes. Now I see it perfectly.
Yeah.
Perfect.
Okay.
Fantastic.
But
yes.
I am not. Let me just. Okay. I think Abraham is sharing the screen.
Yes, I think I see. I see the presentation now.
Okay. Let me see. But I cannot move the slides.
No, you cannot move the slide yet. Okay, why?
Okay, so I will stop sharing my screen.
Okay, stop sharing the screen, and then now I see your presentation.
I think Abraham is sharing the screen. Okay.
Okay, perfect.
Let me know. Because then I can start and.
Yes, you can start exactly, and then you can just next, and he will pass the presentation. That will be good.
Sorry for the confusion, people.
No problem.
Okay, let's go on. That's the problem of doing this remotely with virtual people and some bald guys that don't know how to manage with the computers. Okay.
No worries.
So,
go on,
as I said, I will be much more specific than my previous colleagues, than Patricia and Giuseppe, because I will talk about a specific problem of jellyfish in general. Okay, so next, please. I will try to answer the questions at the end, but I'm not sure. So first, I would like to thank you, the organizers, especially Sergio and all the staff that are helping us to make this possible. Next, please. And of course, we have a lot of collaborators and funding, so all the people, or I hope that all the people are thanked in this slide. Next one, please. Okay, so what are we talking about? I will talk about jellyfish. Next, please. I will ask to move a little bit faster. Jellyfish is it's a general term that is applied to some groups of planktonic animals, mostly cnidarians. And we can also use gelatinous zooplankton, or a recent term that some people, a colleague is using, is gelata. Okay, next one, please. I will show a little bit, next one. I will show a little bit some of the groups that we can call gelatinous plankton. And the next one will just highlight the cnidarians, which are the hydrozoans, siphonophores included in the hydrozoans, but I will be more specific dealing with the scyphomedusae. And this is a small group of animals that I am specialized, but in general, what I will show you, we can extrapolate to all these gelatinous zooplanktons. Okay, next one, please. These are the cnidarians, and the next one I will focus on the scyphozoans. And what are the scyphozoans? They are a class of cnidarians, which we can call it Scyphozoa or Scyphomedusae. In general, common people call them true jellyfish or macromedusae because they have a larger size. Most of the species are larger than 5 centimeters. Next one. And this is a little bit about the diversity of the group. Just because I'm a zoologist and I work with systematics, I always want to show the diversity of animals. So it's a small group, and this is very interesting because we can work with the whole diversity of the group in a short space of time, and this is quite easy. So we have 3 main groups, and they are mostly responding to the environmental change in a similar way. Next one, please. So when you ask someone to think about jellyfish, they just think about what? So I just put this drawing, and what is the main thing that most of the people think about jellyfish? Next one, please. So the first image that we have is stranded animals on the beaches in large numbers or small numbers, but it is most of the people think about it. Next one, some people think about the mythology and the myth of the Medusa and Perseus killing the Medusa, but I will focus not on the mythology but on the real animals. The next one, please. So we are back to the jellyfish. Okay, so next one, please. One thing that I want to talk and I want to emphasize to all of you is that we have to remember that members of the phylum Cnidaria, and this includes corals, sea anemones, box jellyfishes, gorgonians, hydrozoans, blue bottles or Portuguese man of war, they all have a very unique character in the body, which are stinging cells. Next one, please. And this is important because all these animals can cause some harm to humans. Next one. And these animals, they have very specialized structures inside the body cells, and these structures can cause stings because they inject venom in the prey or the predator. Next one. Okay, so here you have a squash of a piece of a tentacle of a jellyfish with several of these stinging cells. There are some specific names, but I will not get into detail because we just want to have the general picture. Next one. So if you look at the tip of a tentacle of an animal, you will see that they have this nettle cell, as some people call it, and this nettle cell has some harpoon-like structure, and they can inject venom in the prey. Next one. Okay, now you see that the little nettle cells can inject venom, and they can cause some injuries to people. I just show some examples. One is a box jellyfish, and the other is a Scyphomedusa. So we have marks of the tentacles and of the umbrella. So in general, the whole animal can cause some problems. Next one. Okay, so next one again. So what impacts of jellyfish? We have also to consider that in general, I will not talk about the details because then we'll have another talk considering life cycle, but they do form large aggregations. Sometimes when you go to the sea, when you go to the beaches, you can see a lot of animals, and these are sometimes called blooms, and they might be episodic and seasonal. They might have several years in the same time. But most of the times these episodes are unexpected. They occur in large numbers when we are not expecting. There are some discussions about the term. I will not get into details again. But it's important to remember that they can occur in large numbers, like this species from the coast of Peru, Chrysaora plocamia. Next one, just a few examples. These large jellyfishes, Catostylus townsendii, the size of a small ball, 20 centimeters in Malaysia. Next one, Crumbioni mastigophora, the tomato jellyfish that appear in the beginning of the year in some beaches on the Philippines, but this picture is from 2016. Next one, Chrysaora fuscescens from the coast of California. Next one, please. Cassiopeia andromeda, an invasive jellyfish in the coast of, in the southeast coast of Brazil, in Rio de Janeiro. Next one, that's me on the picture. But an interesting thing is that this phenomena with blooming and strandings of jellyfish, it's occurring since the Cambrian time. So it's a very old phenomenon. Okay, so this is important that it's part of the biology and life cycle of the jellyfish. Okay, so let's get back to the impact of jellyfish. And another important thing that I want to mention is that, next one please. One thing that it's in the media is, are the numbers of jellyfish really increasing in the world? So some years ago, several colleagues studied a lot of literature and came to an answer about the numbers of jellyfish are really increasing. So I just collected the keywords that came out of the paper, and they said that the rise of the gelatinous zooplankton, or the rise of the jellyfish, are a human perception. They are unsubstantiated. There are some inconsistent data. So there are not much data to really say that the numbers are increasing or decreasing. But in general, papers that came out after this one, we can see a little tendency of increasing the numbers. Okay, so next one, please. So, and I just found in the internet some general thoughts about the impacts of jellyfish that I think will be important for us to discuss, and I will show some of these topics. Next one, please. So a colleague from the US, Rebecca Helm, just wrote that in the blog. Jellyfish are causing major problems around the world. They are clogging fish nets and shutting down power plants, stinging people, and ruining tourism. So this is something that I will show you on the next slides, please. So this is also good. So when I was thinking how to organize this talk, I came to the problems about jellyfish, or the impact about that jellyfish can cause, and I tried to organize it in two different perspectives. So the next one, please. And I wanted to show you and to share with you this idea. So I divided the perception of the impacts of jellyfish in two categories. Next one, please. And these categories are what I would say indirect impacts, and next one, direct impacts. And I try to be, I try to put it in the way that it's the indirect impacts are things that they are not visually recognizable. Is that the right word? Okay. We cannot see it, okay? And the visual impacts, we can see it very, very strongly. Okay, so let's see the next one, please. I put some animation, but it's not working. So the non-visual impacts are, in general, the impacts are negative and detrimental. And I will show that there are also some positive points. So this is a large jellyfish, lion's mane, And we know that many of the jellyfishes, the jellyfish species, they are large predators. Okay, so this is a jellyfish that eat other species. Next one, please. But I will show an important aspect that many jellyfish species, next one please, they will predate fish and they will compete with fish. And this is a very important issue. And it's in some way connected to the previous talks from Patricia and Giuseppe when they were talking about complex ecosystems. So I will show a little bit about food web, changes in the environment, and this is related to human actions over the sea. So we are polluting a lot, we are creating specific changes with reduction of oxygen and global warming, increasing of temperature, and all these changes, the jellyfish are benefiting from them. And this is most important. So this is just an example of a study that we developed here in Brazil with a jellyfish named Lichnoriza lucerna. This is just to show that you can see in the screen the picture of the jelly, and the orange part is the stomach full of artemia, full of food. So this is from the lab, but in the environment, this jellyfish can eat a lot of plankton, and that's the main point. When they are in the environment and they are increasing in numbers, they can eat a lot of zooplankton, but together with the zooplankton, they can eat fish eggs and fish larvae, and these will cause a change in the environment and the food web. So the fishes will not develop because there are not young fishes to grow up. So they are predating the food of the fishes and also predating the fishes. So they are competing with the fish and eating the fish. Okay, so this is very important. So they are benefiting from that. Next one, please. So other impacts of jellyfish that we can say. Next one, please. A little bit of animation. So I will now move from the indirect impacts to the direct impacts, and this causes also a lot of negative perceptions, but they cause a lot of economic losses to mankind. So next one. And the first one that I will show you is let me see, which is the next one, please. Okay, accidents about jellyfish or stinging. Okay, so when most of the people meet some jellyfish, they can have unpleasant encounters. So this is a tiny jellyfish. They are the size of a thumb, little fingers, and they can cause what is called sea bathers eruption. Even the jellyfish, but mostly important, the larvae of this jellyfish, this little Linohyungiculata. This next one is Cassiopeia chamachana. Commonly, there are many species of Cassiopeia, the upside-down jellyfish, but a recent study that recognized what they call it stinging water. So when you swim around these animals, you feel some unpleasant sensations, and this is mostly because they are releasing small packages of cells, but a lot of those stinging cells. So this can cause some harm to people. Next one, please. From the European colleagues, you probably know Pelagia noctiluca, or the sting, the Malvar sting, which is a very beautiful, I think it's one of the most beautiful jellyfish in the world, but it's relatively small, 5 centimeters, 5 to 10 centimeters, but they can also cause a lot of problems when people are swimming in beaches. Okay, next one, just not to go too much. And the excessive or the large numbers of animals in the beaches, this is a newspaper advertisement of a Spanish journal showing that the jellyfish are threatening the summer season because they are occurring in large numbers at the coast, and people sometimes have to the government had to take a lot of important measures and eventually closing the beaches. Next one, please. So this is an advertisement saying that the beach is closed because there are many jellyfish. This is mostly from Australia, when we have the box jellyfish, and they are really dangerous. They can kill people. Okay, next one. So there are also other problems, other impacts. Next one, please. Other impacts about jellyfish, and I will show about power plant shutdown. So this is an image of an intake of water into a power plant that it's full, the grid is full of jellyfish. And in the next slide, you can see that they had to close down the power plant, stop the activities, and then they had to remove all these jellies. And this caused a lot of impact because they wasted a lot of money collecting these jellies and cleaning all the structures. So it's a very boring situation. Next one. And many species of jellyfish can cause problems to fisheries. So this is a species from Japan, Nemopilema nomura. In fact, it occurs in Japan and China and some other areas. But if you fishermen go to the sea, they have huge nets, and when they collect these nets that they were expecting a lot of fishes, the next slides, please. You will see that they have this, there are two boats, and in the middle, the net full of these jellyfish. And it's really large. It's one of the biggest jellyfishes that we know. Next one, please. Again, some other images from Japan. You see the boats, and the guys don't know what to do because there are almost no fishes at all, and only the jellyfish. And this can damage the nets, can even damage the fishes if there are any. Okay, next one, please. It's also another image from this species. Next one. Let me check the timing. Okay, and just an example from Brazil. So I conducted a small project on the southeastern coast of Brazil, in which we went to the sea with fishermen, artisanal fishermen that used to collect shrimps. And just for you to know, depending on the season, the number of jellyfish varies a lot. But in some cases, the wet weight of the net was almost 40% only of jellyfish. So what is normally named the bycatch, they had to throw it all back to the sea, and they lose the trawl, and they lose the fishes and the shrimps. Okay, next one. But there are also some positive points from the large numbers of jellyfish. Okay, so the next one, please. There are some entertainment that we can have from the jellyfish, and most of you have seen, and there are some places around the world, public aquarium, that they have very nice exhibitions with different species showing the swimming, the delicate swimming, the beautiful colors of the jellyfish. So there are many places in which you can see, and there are also some in Brazil. Next one, please, but mostly in other countries. And if you go to Japan, they are crazy about jellyfish. They have huge tanks, huge exhibitions, and it's quite nice. Here, another picture from Japan. And the next one is a very nice one in which they have a big ball, and the jellies are inside and the water coming outside. Next one, please. Good. This is beautiful. But people want to have jellyfish as pets, so there are some companies that they are selling special aquariums to keep the animals, and they are also selling the animals. So this is another topic, another impact that it's a positive impact as I am considering. Next one, please. And also about tourism. If we think that jellyfish are detrimental to tourism in some areas, when they are when people close the beach because of accidents, there are some places in which the jellyfish attract people. So if you have a lot of money and can go to Palau, you can dive in these marine lakes, sometimes you can dress like a mermaid or a merman and swim with the jellies. It's very nice. I had never been there, but maybe I will use a tail like that. But it's interesting because in these lakes, the jellyfish, they have a reduced number of the stinging cells, and you can swim among them without being stung. Okay, next one. It's a close-up picture. Okay, so you can swim with the jellies, and it's very interesting because they have symbionts in the body, and they migrate with the sunlight from one side of the lake to the other side during the day. It's beautiful. Next one. But in some places, jellyfish are also used as food. Next one, please. So in many countries, many Asian countries, they use jellyfish as a delicacy or as a type of food. So if you go to China, Korea, Philippines, like in this picture is from Philippines, people sell these animals in markets, mostly as a dried product, but in some places they also sell fresh jellyfish, like this young lady is showing the photographer. Next one, please. And this is a dried package of jellyfish, a dried blanket showing the jellyfish dried from China, a market in China. And the next one is from little packages of jellyfish from a market in the São Paulo city. There is a Japanese neighborhood called Liberdade, and you can go to the markets and find jellyfish, and also some restaurants they sell jellyfish or jellyfish salad and so on. Next one, please, just to keep on time. So I just want to remember that there will be a very interesting talk about the bright side of the jellyfishes by Professor Stefano Pirano on 15th of October. The session 6 is, am I right? Yeah, I think so. Next one, please. So for us, just to finish, there are also some other impacts of jellyfish. Next one. Okay, so impacts on fisheries, positive impact on fisheries. So these, because people used to consume jellyfish, there are some areas in which jellyfish are fishered. So if you go, these red dots are the places where most of the jellyfish fisheries are occurring. And they are mostly an artisanal work, so they go to the sea with small boats and collect the jellies, and there are a special process of drying and preparing the animals. But it's an industry that it's growing everywhere. Next one is just to show that in the Americas, we combined the effort of several researchers to map where are people trying to develop a jellyfish fisheries. Okay, it's not so common here in the Americas because we don't have many important species, but it's some countries are trying to develop that. Okay, next one, please. And there is also an important impact of jellyfish on cosmetics. Jellyfish are mostly water, but what is not water is mostly collagen. And collagen is being extracted from many species, many jellyfish species, and used as a product in different ways. Next one is an example from Brazil that I helped some colleagues. So we tried to develop or cultivate the jellyfish in the lab and extract the collagen from them to check if it's possible or not. Next one, please. So we have animals in the lab, very small tanks, then they move to bigger tanks where we have the larger animals, mostly 30 to 40 centimeters. Next one. This is a project from a former student of my lab. Okay, next one. And I think that's, okay, just to finish up, I want to I will not answer the question in the main title if we have gelatinous impacts or gelatinous opportunities, but I want us to think about the problem. So I just highlight what I showed you, some jellyfish impacts, some negative impacts. So they are competing with fish and they are predating many fish species. There are problems with the stings, the ability to sting or to hurt people, and this causes a lot of problems in tourism. They can shut down power plants, the coastal power plants, and a very important problem is that they are clogging fish nets and causing a lot of problems to fishermen, especially the artisanal fishermen that depends directly on that activity. But on the other side, there are very interesting and positive impacts. For example, I just mentioned entertainment and amusement. So jellyfish are very delicate animals. If you just Google or just go to the YouTube, you will find aquariums with very slowly music showing the animals swimming. So this can attract people to some places, and also tourism in the case of the Palau Islands. In some places, jellyfish are fished as a product, and they are commercialized as a food, and that's it. And also the cosmetic side, that is a huge industry and a lot of money is involved, especially if we talk about rejuvenation, that you all know about the immortal jellyfish and several aspects. There are some people studying and trying to get some benefits from it. Okay, so that's it. Thank you for your attention. Sorry, please excuse me for all the problems at the beginning, but now we can discuss a lot about the impacts in the oceans.
No worries, Andre. It was very illustrative, and well, yeah, this kind of things happen, and especially when you are, in this kind of presentation. So one, it's not the first time, and it wouldn't be the last time. So I think we have to keep in mind.
That's the funny part of the virtual meetings and the virtual schools or classes. There are always something unexpected, and we just have to laugh about it and have fun.
Exactly. Don't worry. So now we can just, Patrizia and Giuseppe can enter now, and we'll start this kind of roundtable. Will be for a few minutes, okay? Just to discuss some points. There are some questions made by very few questions for the moment, made by the students and the people that is shy, I think. Another question that are more general and we can discuss. So this will work as follows. I will just direct the question or the comment to one of you. And then once we are all together and we are just joining the party, then other people can just make an opinion, a comment, or even a question about the question. So it's just going and trying to make it as fluent as possible. I think people has to enter now. I think Patrizia and Giuseppe have to enter now. Bravo, I think they have to. Okay, Patrizia is here. Hello, and Giuseppe is here. Hello. So this will work as follows. I mean, I will make some questions or comments. Okay, direct to one person, and then after the comment, the other people can just talk about it, talk about the main theme. Okay, so the first thing is just to be to take one of the questions that are from the public. And one of the questions is made by the Professor Paulo Horta, which is the Universidad Federal de Santa Catarina, and he's here now from this beautiful place of Brazil. And Andre, this is for you. He says, can we say that jellyfish are more resistant to low O2 levels? And what about also the eutrophication? What kind of impacts may have eutrophication on jellyfish blooms?
nice to answer a question from Paulo. We studied together. That's very, very nice. We had groups together in the university. That's amazing. And now we are chatting through the internet. But it's a very good question, and there are some studies being conducted about it. Normally, I didn't talk about the life cycle of jellyfish, but there are two main stages, a benthic stage and the pelagic stage. The benthic stage is inconspicuous, what we call it the polyps. And the polyps produce the jellyfish, the pelagic ones. And in both cases, the benthic ones, the polyps, and the jellyfish, the pelagic ones, they benefit from low levels of oxygen. They can survive very small concentrations of oxygen. And this is one thing that eutrophication in general, they cause several changes in the environment, and one of the changes is the reduction of the oxygen levels. And this is beneficial for the jellies. They take advantage of that, and not that they reproduce more, but they have less competitors and they can develop in a more efficient way. And even if we have eutrophication, then we have, in some cases, the increasing of the primary production, so a different food web based mostly on flagellates and on small planktonic producers, and also the jellyfish can benefit from feeding on them and having less competitors, and then they bloom and appears everywhere.
Okay, that's nice, and it's a very interesting question because it has been debated during the last 30 years, which is the rule of low oxygen and a high nutrient load for this organism, which apparently some of the species can withstand with him. This question is more for Patrizia, okay? Patrizia, there is Luis Kotovitz Jr. is a professor from the Universidad Federal de Ceará. He's working, among other things, with CO2 equilibrium and carbon sinks. And he says, at the continental shelf of Brazil, particularly at north and northeast regions, the aragonite saturation state is relatively high, more or less approximately 3.6. Could you comment about ocean acidification impacts in this region? And this is related also with another comment of Paulo Horta, who said that besides planktonic and benthic calcifier fauna and flora, in Brazil, there is a huge rhodolite beds, and this is true. I think it's one of the places in the world in which you have a really vast distribution of rhodolite beds. So the question is, if you could comment about this kind of impact of ocean acidification in these regions where for example, these macroalgae, these red algae are dominant.
Yeah. So I don't know so much about the Brazilian margin, but the fact that the omega saturation state for aragonite is above the critical level is very similar to like an area of study that I know very well, that is the Mediterranean. And we always consider the Mediterranean be a region that is a bit protected by acidification because the salinity is very high, so there is a very good buffering capacity of acidification. However, there is also this issue. There are several issues. The first one that is acidification is impacting at the global scale. So the pH will be recorded, or is recorded probably also in the Brazilian margin. And the two main factors is some species, they got really adapted to a certain range of pH and aragonitic status. So I think small changes can have an impact on their physiology. We see this in the experimental setup. And also the main issue in coastal setting, of course, that is acidification is not acting by itself. There are always other drivers that are maybe even more stronger than acidification. So the idea of multi-stressors, so acidification combined with warming or like extreme storm events or sea level change and many more drivers, of course, can make this area, this coastal area, very critical.
Okay, that's also very, very important because there is an asymmetry in the areas. You show it in the map already, which there are huge asymmetries in the map of this kind of equilibria. Giuseppe, there is one question for you from Paolo, which is always a very interesting thing. It's a very interesting question. How to convince people that we need more marine protected areas in a scenario of growing negationism and the mass of uses of this coastal area. So how you will do it?
Okay, we don't have. I think that that convince people that need more MPAs is not the solution. We firstly have to document the effect of MPAs that for sure is not the same in different parts of the world. So we have different context, and I think that it can be it can be very difficult and if we transfer this message, we need to detect and show the effect that should be evident not only to the scientists that work with MPA, but for politics. For instance, sometimes you have the perception that an MPA is working well, just going there without studies. So I think that we need the high level of management in the wider context and a wider view that not necessarily need only MPAs to do this, but the reduction of stressor can be much more efficient and effective than marine protected areas. So from a management point of view, I think that the solution would be to reduce as much as possible the stressor on the ocean, because MPA alone, as I showed in my presentation, can do nothing against climate change or diffuse pollution or altered sedimentary regimes. So this is my point of view.
I mean, I agree also with this point in the fact that sometimes we have relied completely in marine protected area. So you just put a marine protected area and problem solved, and that's not the point. So
no, it's not the point.
I mean, you are right. So sometimes it's just, hey, we made a marine protected area, so just we have doing good, and then we don't have to do nothing more. And this has been demonstrated to be highly problematic.
And usually restriction create conflicts, and we know about this. So is another kind to see the problem. I think.
This is also a very, I mean, when you make a marine protected area, you have to take into account local people, all the economic and social needs, and so on and so on. That's completely true. Andrea, there is one question of Bruna Gabriel, which is an intriguing question. She said something like, is the mortality of jellyfish can be considered an impact, this immortality? Just talk about this a little bit.
Yeah, that's interesting. This immortality was first detected. In fact, it was always detected in laboratory conditions. So we have to keep in mind that it's perhaps it's a response of the animals on the laboratory conditions. But on the other hand, it's an ability that they have. And it was first detected in hydrozoans, small jellyfish, Turritopsis, Piraino and his group. But also it was also found in some scyphozoans. Not in the same way, but what we can see is that the jellyfish, they can get back into a embryonic stage of development and they can regenerate again. They can, in a sense, rejuvenate. So I don't think it's an impact of jelly. It's just part of the biology of these animals, and they can eventually, in very strong situations, in very impacted environments, they can behave like that and take advantage of this ability or this plasticity in the life cycle.
Yes, thank you for the clarification, because it's very important to say that. So now I have a question for you, Patrizia, from Barbara Alcioli. And it's a very interesting question, but I don't know if there is some work made on that. How the CO2 level may affect sharks. I mean, do you have any information about that? Or I don't know.
Working on that, but I think probably there are for sure indirect effects. So habitat loss, of course, due to warming, acidification are of course very known process, and that will affect indirectly habitats that are critical for sharks. Direct effect on shark, I don't know, but on fish in general, we see that of course when the CO2 level is increasing and reach critical level, for example, many fish change their behavior in a way that is anomalous. So in terms of probably predation or predators are like acting in an anomalous way, that it goes against a bit the long evolution that they had in the natural environment. So maybe in terms of like behaviors as well. But yeah,
Okay.
I don't have specific studies in that.
I knew. I mean, in my knowledge of fishes and also of other kind of vertebrates, like for example elasmogrants, I knew something about fishes and oceanification. But I have to be honest. I don't know if there's some experiment made directly with elasmogrants to know that. Giuseppe, one of the things that we have in mind from your presentation, do you think we will go? Do you think we will just back up to some pristine environments, or that is no longer a possibility?
Okay, this is a problem of what we consider pristine, because in times the perception of what is defined pristine is changed. So is the syndrome of baseline shift that I think that and you know, because I've seen one of your presentation, that the target to consider an habitat as pristine is very changed in the last years. Yeah. And generation by generation, we yes, we talk about restoration, but the target of the restoration is not the pristine condition that it happened, I don't know, 20, 50 years ago. So this is it would be very difficult. We have to individuate even with modeling or historical information, for instance, and very long time series, which are the target, the reference condition that we are going through to reach by means of several activities that have to be done in that direction. So yes, restoration is possible, but it depends from what which is the target of our restoration action that we would like to take.
I perfectly understand your point in the sense that the main thing is what you have in mind when we say that there is a pristine environment. I mean, and I agree with you that this is very complex, and sometimes this is not the target, even of a restoration problem. It's not exactly the target. So, Andre, there is another comment here from Jackson Lima, which is a student of the Universidad Federal of Ceará, La Bomar. They say, Andre, coral reefs are suffering phase shifting from corals to macroalgae and other structures like gorgonia and so on. Can we say that nekton is suffering phase shifting as well from fish to jellyfish?
Oh, it's a very good question, Jadson. If you search, if you do a Google, you search for the term jellyfication. In some environments, you are completely correct. There is a shift from a fish-based environment into a jellyfish. Some areas are experiencing a huge fishery, so they are extracting from the environment a lot of fishes, and the jellyfish they have no competitors because the fishes are competitors of them, most of them, and especially the plantivorous fishes. So in certain environments like the Benguela current and also at the Humboldt current, we are kind of having this shift from fish-based to jellyfish. That's a very good question, and there are some literature about it. So if you just have a look, you will find a lot of interesting information.
I have a question for the three. Now, it's not a question, it's a comment that I want to share with you. One of the persons, sorry, because I don't remember right now the name, say that this large-scale approaches are very important, as Patricia said. She talked about the global change that we are looking at, we are suffering. So one also pointing out that there are locations and particularities. But on the other side, also Giuseppe told us that from Halper models, and I agree with that, sometimes there is so much information that is not present that it's difficult to just have a clear picture. And as usual, we say no, but at local level, we have to apply at local level. So what do you think, because this also applies to jellyfish blooms and the problem of the jellyfish, from your point of view, what is the role of these large-scale studies, apart of having an information that may be useful for stakeholders and politicians? What is they are correct, not correct? What do you think about that?
Who will start?
I can start. I think they are fundamental, but I think they are not sufficient. So for sure, I think we need this type of global approach to understand the scale of the problem, to understand eventually the overall critical regions. But of course, to link this to the actual knowledge that we need in terms of like reducing the effect of the drivers, adaptation, policy, and so on. we need, of course, to fit much more refined type of model at a local scale that are even linked to like social model that are linked to the needs of the regions. So, and I think this global model is also very important because eventually also they're linked with these more regional models. So they are complementary for sure. But yeah, solutions and adaptation will come from this more local type of approach.
You have any other opinions, questions about it? You have some thoughts about this question?
I think we should have combined the efforts to have this more local studies, because in some regions the problems are completely different. So we have to integrate those different views and those different perspectives into a more broad approach. But as Patricia mentioned, there are some problems that are global, and we have to face those problems in an integrated way. And I think this is not for us scientists. We have to warn people and we have to advise people, but we don't have most of us don't have the ability to discuss in a general view, like policy stakeholders and so on. So if we go to the United Nations, we will have a very good presentation, but it's very technical. We don't know how to deal with people and with the politicians, and that's something that some people have this ability, and these are our leaders among the scientists, and they can have this position. But I think we are more on the side that we are advising the people that can take the decisions, and the more knowledge we produce, the more they will have, the more substantiate the decisions will be. And I think that's the way.
Okay. You have some thoughts, Giuseppe, about that?
Yes, I perfectly agree with Andrea, and I think that even in this period when we have seen with COVID-19 that is a problem that should be faced at the global scales, I think that the same approach should be adopted for protection and for other problem that affect environment and not only humans.
Yeah, I think so. I mean, this kind of approach is very important because, for example, when you want to approach some kind of global thing, and you have to consider, of course, the different scales, spatial and even temporal scales. And it's not easy at all. And you find that sometimes you don't have reliable data. For example, from the bottom of our seas, we do have the mapping. We do have it. We have the mountains, the sea mountains, we have the canyons. We know exactly where the reach is. We know very many things, but we don't have the habitats. We have 5-6%, more or less, that is mapped from the habitats of the, even in coastal areas. Even in coastal areas. So sometimes it's very difficult to have this kind of, and in this way, I have here a comment that is linked, and I want to share with you, of Paulo. They say, we have data now that shows that we need to increase global effort considering conservation depending on the ecosystem. Since we need to achieve 40% of our environments in no-take marine protected areas. What do you think about that? Because this is a little bit sometimes risky because of what you say, Giuseppe, about and the overlapping with the local people and the local needs.
Yes, because for me are numbers that is very dangerous to put this target, because they say that yes, we have to protect, but we know, for instance, that in Italy most of MPAs implemented are paper parks, so the quality of the MPA and its role in enhance the stability of the system, even to face the increase of pressure that's come from outside the MPAs, must be evaluated by means of long-term monitoring, for instance, that and MPAs that have long series of data are I know that are really few. So again, we cannot put these targets because another problem is that the risk is that once reached this target, at the same time, that could be an increase outside in the other. So the increase of protection could be conducive or increase of pressure outside the boundary of MPAs, like it's happened, for instance, in before the institution of the biggest MPA in the north of the globe. That before the institution there was an increase of stressor on fish stocks that presumably it will take more than 50 years to recover from this. So for me it's like before I say that we don't have to convince people, we need to change the approach to think at global scale, and the number of the 20 or 40%, yes, could be enough, but at the same time it should change what happened outside, because we have only one ocean. And all is related, and what's happened in an area that is not affected by the presence of the MPA could affect the MPA that is in another area.
Yeah.
So
it's sometimes it's very difficult and depends. It's very asymmetrical also, because as you say, it depends also on the human pressure of the area. In the Mediterranean Sea, making as large as, for I don't know, 45 kilometers marine protected area is very difficult. I mean, it's not impossible, but things have to change so much. Patrizia, one of the things that we have all in mind is these potential future scenarios. In this sense, seeing what we are seeing now, what do we guess that will be the future scenario, more plausible or more, how can I say, from your point of view, can we still going to the correct way for climate change? We are still, in the very risky zone, or we definitively are beyond the risky zone?
I mean, it's not a very easy question you ask me. It's a really,
I know.
Nobody knows, of course. Nobody knows that this year will be COVID and the CO2 emission will drastically be reduced. And it was just something you couldn't anticipate. But of course, since COP21 and in Paris, it's really, really clear, like that if we follow one scenario, we will have really anticipate the results on temperature and so on. So the trajectory now is very similar to the trajectory that we had a few years ago. Not so much for Europe, not so much for some areas, but in general, when you look at the global emission, this is a global issue, so we have to look at global emissions. And it's not so much different than before. But of course, there is always hopes that economy will change and the way we live will change. But yes, it's something very radical that has to change, of course. Yeah. And now there is much more awareness, of course, of the problems. And there are things happening all the time that are linked to climate change that are affecting our life. So I don't know, I have hopes, of course.
We are all hopefully that we have hope that someone takes really, a stake about that. And for Giuseppe, there is a question about one of the students of Università del Salento. I say, hi. First questions. There are keystone species at the moment that can regulate sea urchin in the Apulian region. Is there some key species that may just be as a controller of the sea urchins or not?
No, like I showed before, the keystone, the control of sea urchin population are fundamentally the sparids, big fish that has been in many places depleted by overfishing. So I think that we are observing a decrease of sea urchins in the last few years that I had the opportunity to work on this issue for the Berchis project that was aimed to restore a barren ground through the removal of sea urchins. And in this study, we observed, of course, a decrease in the site where we make the removal, but also outside the reserves. And we are going to monitor the shore to see if the dimension of this phenomenon, because I think that climate change and acidification, like my colleague Ziberi said, that could have an effect on these organisms that have a carbonate skeleton. So, for instance, during summer, just snorkeling, I've seen a lot of sea urchins having problems, having stress signal that could be driven by the alteration of thermal regimes or other factors that are changing in the environment. Even the rise of turf species that are macroalgae that cover the substrate where sea urchins stay and lives could be a problem from this species that likes too much to stay on clear barren substrate. So there are, like I said, a combination of factors that could affect the population dynamics of such herbivores.
Okay. Well, yes, that was also related, I think, with because Andrea just made something like another question, which are related with alien species and tropicalization about this vermocane, this the potential rule of alien species in the control of other species, local species, and so on. But in any case,
that, yes, I know the issue, but I think that the Hermodicia effect is driven by another process that are affecting the health of the sea urchin population. So the feeding habits of Hermodicia are not of an carnivorous.
Yeah.
Are not carnivorous. So they felt the deaths in the environment of the sea urchins, and they goes up and is a quite easy prey to catch. So for me, is this the reason? But we are studying this and
still observing.
Yes, we are still observing. So is in progress. Is something in process.
Still observing. Yeah.
Yes.
So just to finish, because we have now just a few minutes to close the session, I will make you a question or a comment that you may think about it. It's just just have a think about what we have been talking about impacts. What will be the more general take-home message that you may have about these impacts on the oceans from your point of view? I mean, which could be the general guides to diminish a bit or diminish a lot these impacts in the cases that you have been talking about? So just we can start with you, Andre.
Well, I think that I think I will step on the position of my colleagues Patricia and Giuseppe, but from my perspective, any changes, general changes, will have small details that are happening behind them. So if we look at a small scale, like I showed just some examples from the jellyfish, but this can be applied to other groups, and the take-home message is that mankind is changing a lot the environment, and most of our activities are producing changes in the environment, and this is causing a lot of shifts, as Giuseppe mentioned, in the dynamics of the environments, a lot of general changes, as Patricia showed, with the cycling of the pH and the calcium cycle, depending on the species. So we scientists have enough material to discuss in a broader sense. That's what I think it's we have now.
Okay. Giuseppe, what's your opinion about that?
Yes, I perfectly agree with Andrea. I don't want to repeat it, but yes, as I mentioned in my presentation, we have to change, and yes, the observation can be at local scale, but the problem to be solved should be faced looking at a global scale. It's like the previous questions about the role of Hermodice. Yes, I can see that Hermodice is eating sea urchins, but I think that there are many factors that are affecting, and we have to concentrate our attention on what is happening on a global scale, because otherwise it could be a problem that regard just the Apulia region, for instance, but the problem is at a wider scale. So yeah. We have to change the vision, I think.
We have to deeply change the vision.
Thinking locally, but acting globally, no?
Okay. And what about you, Patricia? What you would say?
So just to add, I mean, they already said most of everything that I wanted to say, but so we know that we are, as a human, are already altering the environment, and it's obvious, it's everywhere, basically. And I think in terms of state of knowledge, we acquire a lot of knowledge in terms of physics, chemistry of the ocean, and also in terms of like species-specific response. I think there is still a lot of work to do in terms of like community response, community interactions, and we know that since few years we are starting now to understand a bit more, but I think we still need to do much more in that direction. And in terms of understanding and doing something for the environment and for us, I think, yeah, the understanding the interaction between the different drivers at the local scale, like we all say that, and I think that's important. And also supporting like people and politicians that are really care about the environment and the people. That would be a good start. So I think caring about the environment is an indicator about like how much they care about everything else, in my opinion.
Thank you very much for your opinion, and especially from the La Bomara Universidade Federal do Ceará, but also, of course, from the Disteba and the University of Salento. You don't know how much we appreciate your time, your disponibility, and from my own person, I just have to thank you. Thank you very much for these very nice talks. Really, indeed, I just enjoy it, and many people enjoy it as well. And we will continue this afternoon with this other set of the impacts, the second session that is about impacts, with many other talks, with few other talks about many other aspects of this problematic in the oceans. I think that, we have just now to close. I will say goodbye. And again, indeed, thank you very much.
Thank you. Thank you, Sergio.
Thank you. Bye.
Ciao.
Thank you to all.
Obrigado, André.
Ciao.